we're jumping right in. This is section 1.1 in your books, which you will get someday. And we talk about graphing. The nice part is we kind of ease into this, guys. Today, you should walk out of here being like, ooh, all of that looked pretty darn familiar. Just a side note, guys, I don't do a ton of mental math in here. I kind of leave it up to you and your calculator. So if you guys will kind of have those handy, ready to go, so you can, as we're doing this, like, I don't expect you to do a lot of mental math either. Please utilize your calculators as much as possible. All right. Now, with that being said, this book starts with this as its first, like, information, which I really felt like is something that we know already. If I asked you to graph the point -2, 1, would you have felt like you might have known how to do that before? We're just going to make sure we're all on the same page, though. Remember that an ordered pair goes right or left first, comma, up or down second. The only time that I would say that we really need to slow down on that, the one that always catches people, this guy. Okay, so slow down on that one. But if I was graphing -2, 1, I would go to the left. Negative means left. Up 1, and I would put a dot to show that point. Okay. With this being said, I do want to just talk basics about the Cartesian coordinate system. It does have 4 different quadrants. They go in a counterclockwise order here. So 1, 2, 3, and 4. We've got the x-axis is the one that runs horizontally. Y-axis is our one that runs vertically. Again, hopefully all old information to us, right? This guy right here is the one that tricks people a lot. 0, 4. A lot of people will put that to the right 4, but 0 means I move right or left 0. So 0, 4. I'd be up here. Let's go ahead and label these so you know which one's which. 2, -3. Right 2, down -3. And our last one to the right 1, up 0, would be here. Any concerns with the graphing of a point? Okay, we're moving on from that. They do ask you to do this. We're going to ask you to do this as a table, kind of an introduction to tables here. We're going to do a little bit of an excessive table. You're doing like 1 or 2 of these total, so bear with me here. I get that it's going to be showing a lot of work. But you're plotting a graph based off of these x values. So the table I would like to see you guys make is a column for the x values given. In this particular example, that would be -3, -1, 0, and 2. Then you're going to put in your showing your work column, the function. So our function is 2 minus x squared. And the last column is going to be then our ordered pair, our resulting ordered pair, x comma y. So here is where I'm basically going to show my work, get my answer. 2 minus, and then this is a Algebra 1 reminder discussion. When I plug a value in, I want to do it in parentheses and follow my order of operations, exponents, then things like subtraction. Okay, so something like this is the reason I put this problem on here. First of all, that would not cancel, right? I follow my order of operations. Exponents first, subtraction comes after. So I would do -3 squared. Now, this is also a get to know your calculator moment. If you type into your calculator -3 squared and hit enter, it is going to tell you it is -9 for most of you. Okay, why did my calculator just lie to me? I didn't put parentheses in it, okay? So either you need to know that when you square a number, it's going to turn out positive and just don't type the negative in, or know how to type it in your calculator, that I meant to say, because this right here is actually -3 times 3, right? Because I would square this guy and then put the negative on it. But what I wanted my calculator to do is -3 squared, which would be -3 times -3. That's +9. Don't let your calculator lie to you, which includes if I were to just type this in up here, okay? So if I type this in without the parentheses, it would lie to me. -3 squared is 9. 2 minus 9 is -7. So the point that I would graph for that x value would be -3, -7. And then we'll just go put that on our picture. -3, my work is in the way. -3, -7. Questions on how that works? Again, should look pretty familiar. You have utilized, hopefully, tables before, plugging numbers into a function before, graphing by a table, all of that. We are going to have nice curves here. -1 squared is 1. 2 minus 1 is 1. -1, 1 would be left 1, up 1. 2 minus 0 is 2. 0, comma 2. Right or left 0, up 2. 2 squared is 4. 2 minus 4 is -2. Right 2, down 2. Part of this is just using a table to graph. Part of this is knowing the shape of our graph. If I have something like 2 minus x squared, what kind of shape am I looking at? What's an x squared look like? You guys know x squared. Maybe. Parabola? Remember that word? Yeah? Parabola? So we're going to do a nice little parabola through these guys. Connect my dots. Okay. Questions? All right. One of the things we also talk about when we're talking about graphs of functions is their intercepts. It is specific to the axis. So there are two types of intercepts. A y-intercept, where the graph hits our y-axis. Little side note, your x-coordinate of a y-intercept would always have to be 0. In order for it to land on this line, I would go right or left 0. So it's always going to be 0, comma, some number. A x-intercept is where the graph hits the x-axis. It is also known as a 0, and actually in pre-calc, a lot of times it's referred to as a 0 more often. Your graphing calculator calls it a 0. Okay. Again, to land on this line, that means I would have moved to the right or left, but not up or down. So the second number in each of those is a 0, some number, comma 0. With that being said, your book, and that's fine. If the question is, what is the y-intercept? It is totally fine to just say a number, because this specifically asks what is the y-intercept, and that means what value is it hitting your y-axis at. So I can say, I don't know what that would be, like 4. It can just be a number. Or that would be specifically the ordered pair, 0, comma 4. Both are 100% acceptable answers. Okay? Same thing here, x-intercept. I just put these pictures on the side so you can see that there can be lots of different combos of those. It can have a y-intercept and never hit your x-axis. So no x-intercepts. You would say none. It can have an x-intercept and never hit your y-axis. It can have nothing. This graph right here would not have either an x or a y-intercept. It can have multiples. This one has 1, 2, 3 y-intercepts and an x-intercept over here. They could be the same thing. This one is always tricky. Guys, when it goes through the origin, our x-intercept is 0, our y-intercept is 0. Look out for this guy. Anytime it goes through the 0, 0, the origin, your x and y-intercepts would both be 0. It's always tricky to answer that one. I don't know why, but it is. Questions? Okay. Another part of this section in our book is being able to look at graphs of information and be able to respond to some questions about it. The one that I took from your book is a picture that says probability of divorce by wife's age at marriage. Apparently what our book wants us to look into. And they gave us a probability if the wife was under 18 when they got married, compared to if the wife was over 25 when they got married. This is your probability for, it's highlighted here, if they're under 18, and if they were over 25, here is your functions that go with that. Now, with that being said, This right here, 4n plus 5, take you back to algebra 1 again real quick. You guys remember this equation right here? Does that look familiar? Y equals mx plus b. That's what this is in, right? Y equals number x plus number would be a line. But look at this. Is this a line? So basically what they're doing is giving us like a, what would you call it in algebra 2? Best fit line. Okay, they're giving us the equation of the best fit line. Okay, so that's what you're looking at in these functions compared to this graph of data. Okay, so we're going to look at some questions about this. We've got the graph, we've got the equations. It says use the formula, which means down here, right? These are the formulas. Use the formula to determine the percentage of marriages ending in divorce after 15 years, which is your N value, if the wife is under 18 at the time of marriage. So I want you guys to look at, pick which one you would use, plug it in, see what you get. Which formula would you use? Plug it in, see what you get. Couple of key pieces of information. I needed this right here to know which one to pick, right? So it said under 18, so that told me right here. So I'm going here. Our percentage is going to equal 4 times the years of marriage plus 5. Years of marriage, 15 years after they were married. Okay. Grab my calculator, type that in. What's our percentage here? 65. All right. Okay, that's what the formula told me. That's what my best fit line for the data would have said. Use the appropriate line graph to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18. Let me see if I can make this a little bit bigger for us here. I can. Wife is under 18 is going to be this top line. After 15 years, so this is 5 years, 10 years, 15. So if I follow that up, it would be this dot right here, which equates to, looks like 60%. That's what the data told us. Okay. Does a value given by the model is a fancy word for function or equation. Okay, so if you ever see that word model, they're talking about the equation. So did the equation underestimate or overestimate the value shown by the graph? Well, this is what we got from our model. This is what the graph said. So that would be an overestimate, right? Overestimate by 5%. They predicted 65%. The data said it was actually 60%. Questions? Okay. Another thing that we're going to look at is graphs representing things like a situation in the real world. And what would that look like as a line drawn on this picture? Okay, so as I look at this, what would the following situation look like as a graph if I filled the bathtub? Okay, so visualize this happening. Filled the bathtub, took a bath, drained the bathtub. Okay, my graph is over time, what is the water level? Okay, so as I'm drawing a graph to represent this situation, as I'm filling the tub, like when you turn on the faucet of the tub, it doesn't like, it's not like an instant thing, right? It doesn't just like all of a sudden be like, oh, full bath, right? It takes a little bit of time. And if you got a really big tub, it takes a long time to fill up. Yes? Okay. So a little bit of time is going to elapse as I'm filling the tub, right? And as I'm filling the tub, the water level should be headed up. So let's say, and you wouldn't have to necessarily mark along here, but just so you kind of know, like if I am filling during this time, this is how much time it takes me to fill. The water level would start at empty. I'm assuming your bathtub started empty. And from here to here, we're going to fill, 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 fill. Water went up, 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 up. Okay. Now, during the time that I'm taking the bath, what would my water level look like? Is it going to change? While I'm sitting in the bath, does the water level go up or go down? No, it's just going to sit there around me, right? So I'm going to take the bath, but the water level would not change while I sit there, right? And then I drain the bath. And again, it's not I pull the plug and all of a sudden the water's gone, right? It's a little bit of an elapsed time. So here's my elapsed time to drain. Starts here, and I drain it, drain, 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 until it is empty. Okay, so you can kind of see how we would develop these graphs and think about real world situations and how those could be pictured on a graph. Okay, now with that being said, I probably would not write any of this down here. I would have just drawn this line, and that's what you guys are going to see and interpret when you guys are doing your assignment tonight. Okay, any questions for me? All right. So here's what we're going to do. We have decided that we are going to severely shorten your assignments this year. Is that we want to not send you home with lots, but that means you're going to do a little bit in here, and that's where your dry erase markers come into play. Okay, is that from each section we made them short, but then we also took out problems, and we're going to do them at the end of class here on your tables. Okay, so what you're seeing here is a sample of your assignment. Hopefully we'll eliminate questions like, I don't even know what these directions are asking for, because we'll run through it right here real quick. Okay, so those of you that were very prompt in getting your materials, get out your dry erase markers. Those of you that were not prompt in getting your materials, you are about to luck out. Yeah, you can't hide under the desk because you didn't get it. So you like sinking away. Because I have leftover markers from last year. We got to use them up anyway, right? So you are my first class that are getting these anyway, so you are about to get gifted some markers. I don't know what shape they're in, so good luck. But all of my markers are stored in that back drawer there. You may go help yourself to a marker, and it is now yours. My gift to you, Merry Christmas. Go grab a marker. And then grab some hand sanitizer while you're back there. Okay, once you have your marker, this is your first section on your assignment. Like I said, we're going to do very minimally of these. So we're going to do one in here, and I think you have one or maybe two on your assignment. Give me a table, plug in your values, and then draw me a graph. If you just got a marker from me and it's dead, throw it away. Yeah, throw it away. Once you have your table drawn, go ahead and draw your graph. And once those two things are done, you can compare with your table partner. The directions kind of got cut off, so it does wrap around to 1, 2, and 3 on the second line there. Yep, and go and graph it. Do you have a sister who looks just like you? I have no idea what the rest of your face looks like, but your eyes look the same.
Really?
Yeah. Totally spotted it from up there. I was like, that looks just like Zoe. We'll have to talk. I would love to know what she's up to now. Is she? Guys, looks like we're doing wonderful. I'm very impressed with showing work. We're all it's awesome. Awesome, awesome. Just that one. Yeah, because 2 squared would be 4. And then 9. Did you do 9 minus? Oh, you did 2 minus.
Oh, that fell off. Yeah.
Like, that does not seem right. Yeah, this is the directions. I screen captured this straight out of your book. Notice it like wraps around, and they also wanted you to do 1, 2, and 3 in the table. So I see some of you have like half of yours, and it's not like completing it. Just so you know, that is identical to what you're going to see on your assignment today. Any questions on this first one? Very much picked this one because of the subtraction here and because you're squaring. And when you square, it comes out positive, but then you subtract it. Want to make sure that we're getting all of that correctly in here. I'm going to simplify my table real quick. I'm skipping the middle part here, but what were we doing? Subtracting this from 9, so that would be 3 squared is 9. 9 minus 9 is 0. That'd be 4. 9 minus 4 is 5. 9 minus 1 is 8. 9 minus 0 is 9. 8, 5, 0. Those are the values we should have gotten. Questions? Nope. Nice smooth curve through this. It's an x squared. There's your graph. There is yes, actually there are tissues back there too. Yep. Yeah. But I would suggest, guys, bring a old washcloth. They'll work great. Okay, this is like another section in your book. This one should be pretty quick. It's not working very well, is it? That's all right. It'll with the spray, it'll come off. So when you sanitize at the end of the class today, it'll go away. This is one of the sections that you guys will be doing on your assignment, and it has 2 parts to the question. Part A, determine the x-intercepts, if any. Part B, determine the y-intercepts, if any. And you just look at the picture. Okay, so I want you to write down x-intercept equals, y-intercept equals. During our notes today, we talked about that you have options. You can put like the x-intercept equals and it can be a value, y-intercept equals and it can be a value, or you can put the ordered pairs. Now, I like ordered pairs for the fact that it very much is very specific to the point. However, it's also really easy to make mistakes with. So, with that being said, I might avoid using the ordered pairs because if you switch where 0 and the number are, it's not the right answer. And you knew the right value, but you wrote the ordered pair wrong. I would hate for you to miss something like that because you did the wrong 0, comma, or comma 0. Okay? Answers on this one, you should have said, what do we do? X-intercept first. Remember your x-axis is here. It crosses at 2. And again, I would probably avoid the ordered pair, but if you picked the ordered pair, that would be 2, comma 0. And if you flip-flop those, it is wrong. Okay? Y-intercept would be, here's my y-axis, hits it down at -4. And again, I would avoid the ordered pair, but that should have been -4, comma 0. I mean 0, comma -4. All right. One more on our check for understanding today. Actually, I have 2 more. This one and 1 more. I'm going to see if I can zoom that up a little bit here. This is the section that will be in your book. You're doing problem number 56. So this one will help us figure out where all this goes, all of that. Picture the blue one is percent of seniors using alcohol. The purple one is the percent of seniors using marijuana. Now, why did we pick this and why are we doing this in this class? Because that seems like kind of like weird topics to be talking about in a classroom, right? Yeah? This book, which is new to us, has a lot of these questions in it. So we're just going to have to get used to it. Also, like our divorce question, that's not a question I've ever had in a class before. But that's what they had in the book. And you know what? It's not going away. So here's our question about alcohol and marijuana today. First question, part A, use the appropriate line graph. So it tells you exactly what you're supposed to be using to answer this part of it. To estimate the percent of seniors who use marijuana in 2010. Put your guess down for part A. Now, when it says to estimate, is there one right answer? If the question is ever estimate, if you are remotely close to that, like you're going to look at my answer key later and be like, ooh, I was close, but that's not the same, you're fine. Now, if my estimate was 60 and you said 92, probably not okay. But within reason. Part B, use the appropriate formula to determine the percentage of seniors who use marijuana in 2010. How does this compare? Guys, this is just like our notes, so go ahead and find the appropriate formula. Just make sure you slow down and pick the right equation. Part C, use the appropriate line graph to estimate the percentage of seniors who used alcohol in 2010. Part D, use the appropriate formula to determine the percentage of seniors who used alcohol in 2010. And our last one, for the period from 1990. Oh, you've got to be kidding me. This is Mrs. Yonda. Okay. 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 All right, will do. Yep. Okay. Got all your answers done? All right. First one, appropriate line graph, and you should, basically it's slowing down and looking at it and then reading correctly. Okay, so marijuana would be the purple one. 2010 is here. So I follow my way up there and then follow it over. And I saw a lot of really good estimates on that. It's kind of like a little lower than halfway between 40 and 50. So I saw a lot of like 43s. I think that's perfect. If you said 45, great. Close enough, right? If you said 70, we need to look at that one again. Okay. Part B, use the appropriate formula to determine the percentage of seniors who use marijuana. Your appropriate formula would have been here. 0.1N plus 43, and I think I saw that came out to 45 if I was looking at everyone's tables correctly. Yes? Good? Any questions? No? Okay. Appropriate line graph to estimate seniors doing alcohol in 2010. Alcohol would be here, right around 70, and that would have been this top one, negative 0.9 N plus 88. I think it also came out to 70. I was looking around correctly again. And then part E, from the period from 1990, so anywhere from here to the end of the graph, which year was marijuana used the maximum? So find the highest point. Here's our highest point. Your answer should have been in 2000. What percent is that? Approximately 50. Okay. Questions for me? All right, here's our last one today. On your table, actually, we don't really need to on a table because it's just A, B, C, or D. You begin your bike ride. And you're going downhill. Okay, if you're on your bike and you're going downhill, think about what's happening to your speed. Okay, so you begin your bike ride going downhill, and then you go up a hill. And when I go up a hill, think about what's happening to your speed. Okay. Finally, you ride along a level surface before coming to a stop. Okay. Discuss with your table partner. Which one of those graphs would represent that ride? Go down a hill, up a hill, level surface, stop. Okay, so this one kind of messed with my head because it said going down a hill, so I thought the graph should be going down a hill, but it's not following the person, it's following their speed, right? So that's where this one became a little bit weird or kind of messed with me because if I'm going down a hill, my speed should actually be going up. So that's why these two could not represent our situation because my speed actually should be increasing at the beginning of this, okay? This one is the one did we pick B? We should have increased our speed, then we rode up a hill, so my speed went down. Then I was constant because I was on a flat surface. I do like this part of it as a discussion. Then I stopped. But if you stop, I don't know, maybe you haven't ridden a bike, but you don't literally just stop like you ran into a wall. It takes a little bit of time to slow down and then stop, right? So that's where kind of like our draining of our bathtub takes a little bit of elapsed time to do that. All right? Okay. Your assignment is here.